Hi, Sean. Welcome back.
Thanks, Adam. Great to be here.
The last time, I forgot actually which release it was, but it's a long time ago. So it's like half a year?
Is it that long? No, I don't think so. I think we spoke in the fall because I think we spoke about our GraalVM 21.3 release, which was an LTS release. Mm-hmm. And I think we put off talking for a couple of releases just so we had some, enough content to sort of go over. Because we have a 3-month release cycle, right? So some months are busy, some are less busy, and then usually because of the New Year break, less work gets done in that first quarter.
Mm-hmm.
So
it was at the beginning of December. So
right,
5 months
makes sense. Yeah, yeah. So we had release in November.
Yeah,
is that right?
And the current release is 2021. And it was, I think, last week. So April 26th was released.
I think it's just before that.
Oh, really?
The 19th. Oh, no, sorry. So actually, that actually is a good topic. So actually, there's the community edition went out on the 26th. I think that's correct.
Okay.
We actually had to release the enterprise edition a little bit earlier. And it's an interesting story. This is the open source world, but we are downstream of OpenJDK, right, for community edition. Mm-hmm. And for Enterprise Edition, we're downstream of Oracle JDK, which, it's almost the same thing, but not really, not quite. So we had the problem in the 22.0 release, I think it was, where at the last minute, like the last day, OpenJDK said there are security fixes. Mm-hmm. So we couldn't ship on the day of. And in fact, you would have seen this with other downstream releases. Everyone had to take the time to absorb those security fixes, late breaking fixes, to do the builds, do QA, bake those images, bake those binaries and so on. So we decided that we would give ourselves time from now on to deal with any lately available OpenJDK security fixes. So it's no big deal. But it did kind of create this oddness in our release schedule.
Okay. But I'm really happy about the 22.1, the recent release. It supports M1 Silicon, which is huge.
Yes, and I have one too, and it's good to have it for sure. I mean, I don't know about you, but so far the M1 transition hasn't been the easiest thing, mostly due to Docker. I've mistakenly downloaded images which aren't tagged as multi-arch. And I learned this morning actually from one of my colleagues. If you're getting an image that's set up as multi-architecture, if you try to pull it, it will warn you, right? Like, hey, no, there's no build for you. If it's not defined as a multi-architecture image and you pull it, it downloads just fine. It even runs, and then you get odd errors. So I tried to get an Oracle database, Oracle XE, right? Yeah. I pull it down.
And after half an hour, you get strange errors, right? So everything works, and then it stops, right? After a while.
No, actually, I had faster failure. So first it was failing on a network problem. I'm like, okay, let me just. It runs in background mode, right, by default. Like this is from Gerald Wenzel, his images, and he puts -D, so you background it, so you kind of don't see it, and you realize this isn't working. So you turn that off. Then it was starting up the container. It was running the shell script to boot the database, and it was failing in there. Actually, yes, it was an interesting error, but it was not obvious, right? You're on the wrong architecture. And I also was talking to one of my support lead, and he was saying the other thing that can go wrong is you have the right architecture for the OS, but you got the wrong binary, right? So now we're in a world of like the OS is changing, the architecture is changing, Docker images. I mean, it's a mess.
Will the Oracle database run on M1? Because I read there is like they in one point of time they will support ARM-based CPUs, right? Because of the cloud. And
I don't know. I have no inside information on this, but it does make sense given that we're rolling out the Oracle Cloud Ampere A1 machines. We have a bunch right now. I would assume this is going to be the thing because ARM is taking over the server space quite well. It's making progress in the server space. But right now, I have no knowledge of this. It would be handy because now I'm in this weird position. I have this nice Apple M1 machine, and some things don't run, right?
Yeah.
In a Docker container, anyway.
I tried last year, I think, and and it worked at the beginning, and then it stopped, and then did some research, and there was some and then there were some discussions around that when it is going to support, and so this was exactly my experience as well.
Yeah.
And the GraalVM also, this was a long on the wish list, actually, a GitHub issue, right? And one of the reasons what I understood is that GraalVM does not support M1 because there was no hardware which had enough memory for CI/CD pipeline, right? So what I read, this was like
it's part of the story. Yes, part of the story. If all you can get is a little Mac Mini,
yeah.
I mean, it's fine for running things on building, and well, actually, tell you the truth, it's testing, right? Like you have some really big tests, and those little Mac Minis couldn't do it. So hardware is the solution. The funny thing is, you could buy, a laptop with enough power, but you couldn't get, somewhere we have a data set. We have a place I think it's in California, where we have racks of these minis, and they weren't really up to it. So it's true, right? The hardware was an influence for sure. I mean, then there's still, you're still on ARM. There's still changes, right? Like optimizing for ARM. And so we already had ARM support. That wasn't the key thing. But yeah, it's silly practical things like hardware.
What was really fun is I watched this for a while. So, okay, this is interesting that they don't have, a hardware to build that. This was not funny. I mean, it's absolutely understandable, but funny because, it is a minor thing which stops the entire thing, right? So it was like,
Yeah, because you got this, complicated infrastructure for doing builds, tests, and so on, right? Like we've got a farm of machines, right? So what's in the farm? If you can only get machines with like 16 gig of RAM, there's not a lot you can do with that farm.
So we have now M1 support, and it is official with 20.1 or once before. So it came right now,
22.1.
Yeah. 22.1 exactly. Yeah. And so it works exactly like Intel. So you can just download GraalVM with native images, no difference, right? So
yeah, I was using it myself on the local machine. It works fine. I was playing with it, because I was comparing, right? So this is interesting to compare. Like you use the Intel version.
Next question: What's the experience Intel versus ARM native image compilation GraalVM?
Yeah, that's the good question. So there was emulation mode, right? So we run the Rosetta 2. Right. Then there was running it on Linux in a Docker container. ARM. I was doing that, right? So this is better. So the Rosetta 2 performance wasn't as good. Then what I was doing was I had a nice cloud machine, 16 core, 64 gig, whatever. I had something beefy in the cloud, and I was trying to measure all the differences. And then there's the native one. So before I had the native M1 build, I was trying Docker local. If I cranked up the memories sufficiently for the VM, I could get actually close to the cloud performance. So this is actually Docker Linux on M1 was equal to this fairly beefy cloud machine. So the performance is good. Now the native one will run, I think.
But the cloud machine was Xeon or something like this, right? Intel.
Yes, it was. It was. So it was a pretty, and lots of memory, lots of cores, right? So you can go so fast. Native image will only go so fast. It will require certain, there's a point at which more cores and more threads don't help you, right? More memory doesn't help you. So, because some of the processes I know are serial and some are parallel. So the parallel processes we win, and then at some point you don't doesn't help anymore. But I have an app. I have a 16 an M1 16-inch M1. Is it Max? Yeah, Max. And it's powerful as that. It's as fast as that big cloud machine.
Okay,
so I'm happy.
That's interesting because the single core performance is not as huge from the M1, right? So actually, I thought that Intel should be actually faster. So it's amazing that it isn't.
Again, it's not just one thing, right? There's memory and there's cores, exactly. And then there's just the complexity. I mean, it's always like your mileage may vary. I was testing something. I don't recall what it was I was testing, but well, what's crazy though is I've got a consumer, Mac Pro, right, laptop that's got this incredible amount of power in it. It really is that fast. Yeah, because it's funny because day to day, if you're using it, maybe you've tried this, right? Everyone goes, "Oh, they're so fast," but when you're using it, it doesn't feel super fast because all the cores are idle. If you watch the cores, two cores, the low energy cores or the low efficiency cores do all the work. So it's hard to try and push this Mac or find workloads that can really take advantage of the cores.
And prior to your M1, you had an Intel Mac, I assume, right?
Yeah, Intel Mac. Yeah.
So what is the difference now between a native compilation GraalVM on Intel and to M1?
Okay, so that 2017 MacBook 13, I would not use it. Right, it has 16 gig of RAM. It was just not usable. I use a cloud machine, just because it was just so slow. It was just so slow, right? Compared to
This was already i9, right? So it wasn't i7 or i9.
I think it's a 7. It's not that great. It was like it's a Pro, but it's like a 13 inch, which isn't the big end, right? It was painful. Like I've gone from like a 5-minute build to like a minute build.
Oh,
right. I think that's the kind of jump I've gone through, and then you play games with. Again, if you're using Docker to build containers, that's where I think that's where I was really paying a lot, because if you really have to crank up the RAM for Docker. No one pays attention, but you install Docker and it gives you, I think, 2 gig by default for the virtual machine, which is not enough, not for native image. So
what I actually did on for GraalVM compilation, I always took spot instances, so unused capacity in the cloud, so I could get actually very cheaply a huge instances. This was fun actually, because you could preload everything and then compile, get the native image, store it somewhere, and this is what I did, and this worked actually surprisingly well.
Yeah, that's actually if you're not in a hurry, it's a good strategy. Did you see? We had a live stream for the 22.1 launch. And Fabio Niephaus showed that he's written GitHub Action support for native image for both Community and Enterprise Edition. And he was doing the builds on an Oracle Ampere A1 machine, because you can get that's in our always free tier. So Oracle Cloud has always free. You get 24 gig of RAM and 4 cores, I think. And so the ARM cores are 1 hyperthread, right? So it's like half a Intel core. But you get 4 cores. 24 gig of RAM, and he was using that as his build machine, or his runner, right, for GitHub Actions. So that's kind of interesting. So it's pretty beefy, actually. He ran it quite nicely.
The GitHub Actions are, how to get them? Are they in a repository, or how to use them?
Yeah, they're in GitHub. They're in GitHub.
Yeah, for sure.
Of course. Yes.
Can I? The project Can I?
Yes. No. It's Project Can I?
Can I? It was a Sun project very similar to GitHub. Cani.com. You don't remember that? This was like 10 years ago, It was like, I think it was a Mercurial-based project. It was announced on Java 1. And I had lots of open source stuff there. So this was just joke now with the Cani. This is no more alive for 10 years or something.
I do not remember this at all. Sorry. No, but it's really good. So we gave a demo. Fabio gave a demo of doing this, and it's great.
I will put it to show notes, so because the GitHub Actions are pretty usable. I assume that you can also have you can compile for different platforms as well with GitHub Actions, right? So I could create images for Windows and Linux and Mac at the same time.
Yes, and that was demoed. I think Todd Sharp was demoing that last year. He had a nice example of doing all 3. Right.
Exactly.
Actually, I think the J releaser is using has a native image. Actually, I'm not sure whether it's production yet, the GA, but using native image, which I guess it will have multi-arch support for J releaser.
Okay.
And it's GitHub Action.
The recent release. What I also read is also interesting. It seems like whatever is annotated ends up being in the image, right? So it's one of the features. So I think. This was my understanding, at least. It says, whatever class are annotated, they're.
What do you mean annotated? You mean annotated to be included?
Yeah, to be included. I thought, regardless which annotations. So this would be interesting, because it would mean, all my Java EE applications are out of the box, native image capable. Yeah. So. Well,
it's funny because if you look at things like Micronaut, right, which is doing annotation processing, you could do this. They calculate exactly what needs to be included.
Yeah, Quarkus does the same, because all classes which are injectable have to be annotated. So I think, this is not that far off. So if you have a GraalVM and you say, all the whatever, if you have annotation on class, method, whatever, it gets automatically included. So this could be actually a viable option.
Yeah, I did see a project that was called GraalVM Hints, I think it was. And it was someone who's written an annotation processor to let you add annotations onto your classes. It would generate reflection config for you. So it's just basically a shorthand. It saves you typing text, right? But I think that I think that we'd like a more standard approach, right, for this. So, yeah.
Okay. Now this was like freestyle conversation. Now go to more structured approach. So what? So the big features, of course, M1 support on ARM support. I assume not only M1, also ARM support, right? So what it means?
ARM came before. ARM was already out for Linux.
Yeah, exactly. Because I know that it already run on Raspberry before, right? So
yep. Yeah. And I had tried that. Again, same thing, right? You can't really compile. You can't run native image on a Pi because it's too small. Or at least the one I have is too small. So I ran on the Oracle A1 machine, and then I put a 64-bit OS on the Pi. When I compiled native image, I compiled it with the option to statically link everything but glibc. So I had everything pretty much I needed. Zlib and so on, and copied the binary over. It works fine. So I don't know how far that goes. I was trying a simple hello world, but you need a beefier machine. I guess I could do it on my Mac in a Linux container now that I've got that working. Same thing. Build somewhere else, but deploy to Pi.
And the A1 Oracle CPU, is it Oracle Silicon or is it what it is?
It's Ampere. Okay. So, and I think that Amazon also recently announced Ampere servers. So, I think Oracle's a big investor in Ampere. So that's one of the business relationships we have, right? So they're building servers and we're buying servers. But I think also Amazon's a customer of those Ampere machines.
Okay, so interesting times. So because Amazon usually has the Graviton, their own CPU. So interesting that they also.
I'm not sure if is Graviton a brand name or is it a chip? I don't know actually.
I know it's a chip right now. So, but maybe they invest in something else as well. So who knows?
But those chips. Thing is the revolution of these is that the cores are cheap, super cheap, right? When you're paying for cores in the cloud, they're like penny cores they call them, right? They're like a penny an hour or something insane. Like the math is just shifting. We're realizing that memory is more expensive now, right? Memory becomes more of a limiting factor than the cores. Cores, you can get lots of them. But memory cost still hasn't come down like the core pricing has come down.
It is actually right. Because, the 4-core machine back then, it was very, very expensive, like a workstation, everything which was multi-core. Right now it doesn't matter anymore.
No. No, it means you need to optimize for memory. Like you can chew up cores, it's okay, but for runtime you need to optimize memory footprint. That's where you save some money now.
But this is still strange because if you're running, for instance, AWS Lambda, you only get more CPU with more RAM.
That platform does that. Yes, this is typical functions, right? But they don't have to do that.
Yeah, exactly.
And you can use Google Cloud Run, right, which is just container as a service. I believe you can choose cores and RAM. I think that's going to be coming. I mean, function simplifies the world for you. But in future, I think you'll see more flexibility.
Yes, because it's one of the reasons why I'm not using GraalVM a lot. Because in order to get more CPU, I have to buy my memory. And if I have 2 gigs of RAM, I don't care. Because my application, needs like 256 megs, and I get 2 gigs of RAM. So I actually memory, it was never an issue in the cloud. Because I would like to have at least one CPU. And if you would like to buy one CPU, you get 2 gigs of RAM. So it's like cool times for Java developers. But if this changes, then it's a big time for GraalVM, I would say.
Well, like I say, it's the serverless platforms are this way. They don't have to be. I mean, if you look at because I worked on Oracle Functions, right? So I worked on the Functions service on Oracle Cloud, and I was looking at the competitors closely, right? Like looking at the pricing and so on. And Google at the time, and I think it's still the case. But you look at Google Cloud Functions, and they have gigahertz and memory. They actually have 2 parts to their pricing. And if you look at it closely, it really was, and maybe I said this to you before, somehow I feel like I said this before, but if you look at the pricing, they were tied together. So it's like, if you increase the gigahertz, you increase memory. Like, so it's an illusion that you have choice, but really you didn't have choice. They both scale together, Yeah. But I don't see any reason why as we go forward, we wouldn't be able to choose both. Right?
Yeah. This would change, actually, what's interesting, right, in the cloud. So the entire cloud architecture is about economics. It changes completely, right? So if you are on premise, so we spend time about performance optimizations and decoupling and modularization, whatever. And if you are in the cloud, costs are the factor. And I was in a project where the budget was like, they didn't care about the budget. I said, okay, but if you don't care about the budget in the cloud, I mean, then I would buy, 2 largest EC2 machines and we are done, right? I mean, then the architecture is over. I mean, then we can, install 2 application servers and it will run, with milliseconds latency and we go home. You get exactly the architecture 20 years ago, right? And it only makes sense, the entire architecture, if costs are a factor. And if they change, the serverless, the economics of serverless, this will have huge impact on the design choices and architectures, right? So
we know that serverless is expensive, right? Compared to if you have a workload suitable for serverless, which is more intermittent, yes. But if you're running 24/7 full out, then you're going to lose money. You're paying too much money, right? Because you're paying a premium for that interruptibility.
Yeah, it's really if you compare it to what? So if you compare it, let's say to containers, right? Or EC2, you are right. Yeah. But if you compare it to Kubernetes, not always, right? Because and if you have serverless, what you can do, this is still interesting discussion because I have to decide or to suggest something over and over again. If you pick something like Kubernetes, the problem you have is you cannot have one Kubernetes cluster per developer. You could have, but it's no more economical. But with serverless, you can absolutely have. So you can have very nice isolated test environment per developer because you are paying per invocation. So it's completely different economics. Yeah,
it's interesting. Yeah, that the cloud is that whole economics thing is interesting for sure. This is
and GraalVM is related because we have the conversation with GraalVM is okay. Look, if you go to serverless, we get 2 gigs of RAM. Cold start is maybe a problem, but this is the GraalVM is in Java comes always into discussion now. If you're in the cloud, it's like an interesting topic.
Well, there's a series in InfoQ right now on Java and cloud, specifically native compilation, right? And you're seeing the same themes being repeated. The editors made some comments about Java suitability for cloud. You saw this from the Kubernetes article. Alina Yurenko, my colleague, had the lead article in that introducing GraalVM, native image, and it's about Java suitability for cloud. Just take a look. They're making arguments about why are we using native compilation? Not that Java doesn't work. Java works great in the cloud, right? But there are advantages for sure.
The advantage of cold start, right? So with the native image, you get even faster cold start. So you can save some money for sure right now.
Yeah, I don't even think everyone talks about cold start. I'm not sure cold start's the big thing because, like you said, in Kubernetes clusters, like a thing of a pod takes forever, right? If you're on shared compute, you'll see this. Like if you were managing it yourself, you would see a benefit. But it's resource consumption. Right. So if you can cut your resource consumption, again, back to memory, if I can cut memory significantly, like the example the Spring team had posted was 75% memory savings on Spring Pet Clinic, right? Compiled.
Yeah.
75%.
This is what I also observed, Quarkus on JVM and on GraalVM is even more. It's like you saving 90%. It was incredibly small.
Yeah. And no, this is if you were compiling a massive app server, it would be different. But there's a smaller application, so that it's more pronounced. The savings are pronounced, right? So I think that's where you see it. And again, if cores are cheap and memory is expensive, then you're optimizing for memory. You want smaller, right?
Yeah,
you want lighter.
If they change the economics, right?
Yeah. we need really cheap memory. Well, if we got cores cheap, we need memory cheap, and then of course network, all the pieces, right?
Okay, next feature, Sean.
Yes, I'll give you the features, or do you want to tell me the features you want to know about? There's things in 22.1. There was a big feature in native image around the quick build. Did you see the quick build?
We had already a chat the last time about quick build, right?
No, it's a new feature.
Yes, came out. But maybe you pre-announced that. So there was we talk about options that you can decide, whether you would like to a faster build or.
I think I told you we were working at it. Yeah, so it's come out.
Yeah.
So there's a -0 for optimization, you can do B for build, so minus O, B. And you end up with significantly faster build times, like much faster build times, because we basically just aren't doing optimization. It's the old, I'm in dev. I don't need all this, high level of optimization. Turn them off. Don't do them. The images are bigger because we're not spending so much time excluding classes. They're a bit slower because we haven't optimized the code to the extent we would, but it gives you a faster turnaround. So if you're using like the Maven or Gradle plugins, you can build a native image and it can bake your JUnit tests into the binary and then run those tests, right? So you can do that in a relatively, orderly manner, right? Like faster, right? Rather than waiting 5 minutes, you're waiting. Well, what's the number? I've got a example here. This again, I hate to say it. I think it's Spring Pet Clinic because it's the most well-known example, right?
Spring Pet Clinic JDBC. So according to the show notes,
that's the one. Yeah, that's what I've got. So what is it now? So in 22.1, regular build is around. Actually, I think I put a note in here, didn't I? 22 is 2 minutes, and it's about 2 minutes for the build. And with the quick build, it's down to about 115, 117. So you shave off quite a bit. I think it's, how much did I say here? Yeah, it's 38% faster, right? Which is a significant savings. So this is our first go at this, though. So this is the first time this feature has been released, right? And like
how much worse is it? From, size, the disk size doesn't matter, I would say. But the start time and the performance, do you have?
Start time is fine. Start time is still fine. It's more the throughput will not be peak. Right?
Okay.
So we won't have done as many optimizations because we do a lot of enrolling and inlining and stuff that we won't do. Just so you can know, okay, yes, everything is baked into the image, like it's there. What you said you need is there, so you can run your tests and you can be confident that it's there. So the start time is the same because you think of start time, we're basically just not doing all the JVM startup, whether it's optimized or not, right? We don't start it. We're not starting up the JIT compiler and all that stuff.
So what's the use case of that? The use case of that is to pre-check whether the build is going to be successful, right?
Yes, and get rapid feedback. Right.
Okay.
So one of the things we are bad at today is failing fast. Right. So you always say fail fast. It fails fast, too fast. So it fails on your first bug, right? And then you want to go around. So what we are obviously looking at is, can we not do that? Can we collect a few things and not just fail right away? So that would be good. But right now it's still in the mode, the same mode of if you hit a terminal bug, it's going to stop the build. So you want it to iterate fast. When you get to that point, right?
JFR events is the next one.
Yeah, there's a few more added. This is Red Hat. So Red Hat's been really good about contributing support around JFR. And so in a previous release, we had basic JFR infrastructure available, although really very few events. You could do a custom, but not much. And now we're starting to see real actual events being implemented. So there's a long list to go through, but it's improving. And that'll make it easier for people to monitor the native executables in production.
Ah, okay. So maybe they are doing this because of OpenShift, I assume, right? Because they would.
I'm assuming they have a good motivation, and we have the same motivation. We were doing the same work. So what's great minds think alike. So we were working on JFR also, and they are working on it. So we basically combined forces, right? So they're building it out, and I think this is actually really good. And JFR, since it was open sourced, I don't know. What do you know? Do you think people are using it more? Because when it was still a closed feature, I mean, even people who were using Oracle Java Advanced or Java SE Advanced, which included that, didn't really know it existed, didn't use it.
It was also a secret weapon, right? So, I mean the JMC and JFR, right? So the Java Mission Control, this is what is known. And what I remember back then, I asked the Swedish guy. I don't think he's at Oracle
Marcus.
Anymore. No.
Marcus
not
Hirt.
No, Marcus Hirt. It was someone else. It was he was in charge of Java client in one point of time, and he told me that no, he I have to find a blog post. He said, okay, you can use now JMC, in development for free. So this was like official Oracle statement, and still people didn't believe me. I said, okay, yeah, okay, but we used from then. It was like maybe 5 years ago or even more. But in all, task forces and performance-related projects, so JMC was used everywhere. So everyone knew about that. And the killer features were, of course, that we could find out about the deadlocks without the contention was easy to find, and without slowing down the application. The problem with the other profilers was that if you profiled something, so actually changed the execution of the application, but with JMC worked better. And then we used the events inside without thinking about that, because what you could do is say if something happens, the event should cause something else. So we use the events for automation. And Gunnar Molling?
Oh, I see. You're using it as like a messaging, like infrastructure, like this happened. And you were
this happened, and I don't remember. So we said, okay, the application didn't behave. So if this event happens, then JMC did something. I remember you could internally, react to the own events, right?
Yes, you can.
Yeah.
And this is the feature we had early, was custom events, right?
Exactly. Yeah. And then I don't know whether you know Gunnar Molling. He works on the BSIM project. He's also very active with JFR. And what I wanted to do for a long time is actually to read the JFR events and send them to Kafka, let's say, and then have analytics outside just for fun, because I could get a large amount of events and do something with it. The only problem is I have too much real projects going on, so it never happened.
This is
the JFR to Kafka bridge, but this would be actually, if I will find some time, I will do it for sure, because this is actually fun. So I would say. The JMC and JFR is actually taking off in projects where they need the performance, and so I would say it is as successful as it could be, right? If someone uses something for profiling, it uses JMC. This is my observation.
Right. It's so funny, right? Because it's not new, right? It's been around for such a long time, and yet
since JDK 1.3, this was JRocket, right? It came with BEA actually.
I don't know the history. That makes sense given who's involved, the team who's involved with it. Right?
So my information is that the entire JMC and JFR worked with the JRocket JVM, because it worked differently to the Sun one back then, and they needed the performance profiling for the JVM itself. So they were able to emit the profiling information to the tool without slowing down the application, because they needed information anyway. And then they, I think Oracle or Sun, I don't even know, bought JRocket, and or JRocket was part of BEA.
BEA.
Yeah, and then they bought both, but and then they merged JRocket with the Sun JVM, and then and this is how it happened. And then after a while, it became open source. And the open source is actually a huge success, I would say. It's just it is truly open source, and the Oracle JDK is also open source. And I'm surprised actually.
Did they win? Mm-hmm. Didn't they win that? There was a Twitter, battle of the features that I think Chandler was running, and did JFR come out near the top? I think it did. Did it win? No. Actually, no. What won? What won was usable null pointer errors. User-friendly null pointer errors.
Okay, this is
which was a minor feature, but it won best Java because of course it's useful, right? It's popular.
So it means that on that note, someone, this was a null pointer exception. So, someone presented me a pattern a long time ago, and I say, look, I could improve the performance of my application, and say why, how, and I said, okay, he had a pool of null pointer exceptions, and it created lots of exceptions at the startup of the application. And then if something happened, he was able just to throw the already existing exceptions, and this saved back then some milliseconds. Like, look, but maybe the stack trace is no more correct, right? Because but he was really into this idea. So if such a projects readable NPEs maybe make sense, but JFRs is huge, and the recording itself is great. I would say the biggest feature of JMC that you are able to record offline, or how to call it. You can record asynchronously the entire stuff and analyze later.
Yes, that's right. And you can run the rolling file, right? So you can do the black box. right? Like the flight recorder, it's the black box. So, and I know when I was working on this application container cloud service, Java SE in the cloud in a container, we had JFR support. I said, check the box, turn it on, right? It doesn't cost you hardly any to have this black box running, and it keeps so many meg of data. If it crashes, you go look at it. And people will go, really? I'm like, yes. It's for free. It's there. So,
yeah, actually, it should run the entire time. You're right.
That's the whole point. Yeah, if it's consuming, let's say, less than 4%, maybe depends on how. I mean, obviously, it's still non-zero, but it's quite low, and you can leave it on all the time. And it is a rolling, fixed size file. It will maintain for history. Goes down. You've got the last few minutes.
Yeah, and looking at JFR events, everything is garbage collection related. So what was contributed? Yeah, GC phase pause and GC phase pause level and garbage collection.
You can see what they're working. The team's working on there.
Yeah.
But like I say, I think those came from Red Hat, so we're giving them all the credit.
Yeah, Red Hat is great, and seems like Quarkus has some garbage collection problems, maybe, right? So this is
that was the first thing that. Yeah, we really need some insight into this garbage collection.
Yeah.
Well, we could maybe read that in the tea leaves. I don't know.
Yeah. What is the next one? So static synchronized. Okay, this is a minor one, seems like.
Yeah, there's a few. Again, with a project like us, so if you look at our release notes, like I don't know if you're looking at a Linus blog right now, but if you look at the release notes, there's a lot of low-level features that, they're under the cover. You don't see them. Like a lot of the compiler team does a lot of stuff in terms of fairly arcane, like loop, unrolling, avoiding extra checks, a lot of low-level stuff that you don't see. We don't talk about too much because it's very focused, very small. Right?
But static synchronized could be big, actually, right? If this is a locking, I mean, this is why I'm asking, because the others.
Which feature are you looking at? Remind me which feature you're looking at.
Improved handling of static synchronized, and this is I'm looking at the release notes. Show notes come later, but static synchronized methods. The lock is no longer stored in the secondary monitor map.
Okay, yeah. So you're looking at a compiler optimization.
Yeah. Sounds interesting.
And then we'll be benchmarking that, right? So everything we're doing is heavy benchmark driven, and so the game will be in the small. Like if we have our test cases, how does it affect the test cases? So we will say things like in our release notes that if you have loops that look like this, these loops could be optimized. Now then what we do is, of course, we run these in the large. We run just large applications, larger things, to see whether they have a regression, because who knows, right? It could be some weird side effect, but typically not the case. But in the last year, I'd say I keep seeing a lot of loop optimizations. That's the one that keeps coming to mind, is right, loop unrolling, loop parallelization. Anyway, the team does more than that, but that's what sticks in my brain. So there's those. But I think the other thing, back to major features, which we haven't talked about, is in 22.0. There was a large change in the output, right? Native image build output, significantly more user friendly. So that's a big change. So the theme is kind of usability, like developer usability. So making it faster so you can get better feedback is in 22.1. And then in 22.0 was really improving the output, so you could see things like how many classes are we looking at, how many classes can we get to, or even methods can we get to from your program. Which packages have the most are contributing most to your application, that kind of thing. So part of it is just gives you a better feeling that you can watch it doing something. Watching a compiler do nothing is very boring, also non-informative. So this is really just more feedback for the user, and that's the biggest thing I think we did in 22.0, at least in terms of
WebAssembly also, which can be actually big. So you have some improved compatibility with GraalVM WebAssembly runtime with the Truffle framework.
And so we can run WebAssembly,
And WebAssembly could also be, it's already getting bigger and bigger, especially in serverless world, edge computing, stuff like that.
I've seen this more.
Yeah,
it's true. Yeah, I saw, I know, I was attending I attended the UK Smalltalk user group the other week.
Yeah, of course.
Gilad
you have to
attend. I know, I did, yeah. Well, Gilad Braca was talking, and he was presenting on Newspeak, which is it's been around a while, but anyway, he's giving a detailed talk on this and demos. And one of the things he said was right now they've shifted the implementation to run in the browser. So they're basically using the browser canvases and so on, the DOM, and also JavaScript as kind of their assembler, right? Mm-hmm. But he did say that they had a version running, compiling into WASM, right? Mm-hmm. And I think he said it wasn't great because WASM's not very good for dynamicism, for doing interpreters. I think that it's just, I know from even discussing with our team that WASM's a bit limited, and I think they're working on improvements to make it more universal, right? But it's designed for simple languages. Simple, non-garbage collected languages for sure, right? Garbage collections, there's no garbage collection.
Yeah, I heard it several times that actually for garbage collector does not work well with WASM, and
nothing built in, right? Mm-hmm. Yeah. So interesting part of that was so Newspeak they're using JavaScript because I guess it's running on V8, which is really fast, right? It's a really fast virtual machine, does good optimization, so they get the best performance.
Yeah,
but WASM keeps coming up, for sure.
What's also interesting, so you did some improvements. So now we focus on Java, but there are some improvements regarding JavaScript, Ruby. So in 22.1 and Python. Okay, Python is a little bit faster, 30% faster and 40% less memory, but no one uses Python, so who cares?
Don't say that. There's a whole group of people who just went crazy, listen. Yeah. Did you see that number? I just saw there was a graph posted on Twitter of the searches done in O'Reilly books, like for help.
Mm-hmm. And for help.
It was over. Now, I know. So you can take this any way you want, but the majority was Python. So either there are Python users or Python is the most problems, right? Like you can definitely say it that way.
Problems with the formatter.
So Python was big, and I guess the searches in terms of the trend also was more Python. So we do see Python as a priority, right? We are working.
So joking aside, so what's really interesting is I don't know whether you remember the 2006 around. There was like Python versus Ruby versus Java. So Java was said to be dead, and Rails was huge, and people like Ruby because of the aesthetics. So what they said, a beautiful language and it looks nice, and Ruby almost disappeared, right? And what's interesting now that Python appears, but I think the only explanation is because of the scientific, computing, like the scientists are using Python, because it's interesting that back then no one was interested in Python really. So there were some frameworks like how it's called this with it was competitive Rails, which was also somehow
Rails.
Yeah. Not Twisted.
No, that's Groovy. Sorry, that's Groovy. What am I saying?
No. It was something with. It's also with no snake something in the name, but the Ruby was the huge winner because of aesthetics, because of the entire community, and now it flipped. So interesting, why, right? So
it's all machine learning. It's the communities, right? It's communities who are using it for sure. The Ruby community was really big on web applications, right? So Ruby on Rails is all web.
But also automation. I don't know if you remember. I think I think Ansible or the entire Chef, I think, is also written in Ruby back then. All the DSLs were written in Ruby.
The GitHub, they use Jekyll for web page generation. Exactly. It's all Ruby, right? Mm-hmm. So it's handy for us because we have experts in the GraalVM team on all these languages. So we have tools like Jekyll. We're like, hey, we don't know we can't make the website build. We need some Ruby expertise. Good thing we have, Benoit is available. But our Ruby performance is really good, right? That's the thing. So Ruby is interesting because there's still a vibrant community, some large users of Ruby out there. I think Airbnb, I know Shopify, some large users of Ruby out there. So it's not going away. Python has just made its way into all this machine learning and also universities, right? It's an easy language to learn. I mean, I did do some Ruby programming, and it's a bit odd. It's a bit of a hybrid, right? So it's got this. I was attracted to it because it had the small talk like blocks and such, but then it's got Perl-ish, all caps environment variable Anyway, it's a hybrid in some sense, right? So I disagree with you a little bit on the aesthetics. Looking at Ruby has never been my, the favorite thing. It does look a little bit Frankenstein-y, but
no, it was not. It's not my opinion. It was the opinion back then that the Ruby is a beautiful language. So this is what I heard over and over again. And Java is ugly and will disappear and is dead already. And I was asked why I'm still doing Java and not Ruby. This was 2006. This is why I know it. Even look at my blog that there were some comments in my blog post even from the DHH. Because I said, okay, Rails is a little bit strange with the transactions. Some projects were inconsistent, and he even commented on my blog back then. So this is what I remember. And Python was, and by the way, the framework is Django. It was nothing with snakes. What I meant. Okay. Well, this was the Django Django and Turbo Gears. They were the two frameworks I remember. And there was the fight Django versus Rails back then, and Ruby almost disappeared. At least what I see in projects, and Python becomes stronger, even in serverless computing as well. So the Python is I would even say even more popular than Node.js for no reasons. This is my observation.
Ruby definitely peaked. I mean, nothing ever goes away, right? I'm just thinking of Heroku. Heroku had heavy emphasis on Ruby, I think, exactly. Way back, right? It was a thing they wanted to support, but. Yeah, Python is important. I mean, it's just getting adoption. I think it's just easy to use. I mean, Ruby is certainly concise, right? I think that was the attraction to Ruby. It's a nice, concise language, But I don't know. So GraalVM, our project is all about, can we run all of these languages on the same runtime, right?
Yeah.
So
and what you also see R support, which is interesting. And the first thing is, which I didn't knew about, I learned something new, Java GD.
Java GD.
This is in official release notes. Java GD is, and this is related to R, a graphics device route, Java graphics device. Never heard about that. And this is.
I think this is this is the R support.
Yes.
One of the key use cases with R is generation of graphics, right? Graphs. So you do some analysis. We're getting back some kind of image. So maybe that's what you're looking at.
Yeah, exactly. So it seems like this R uses Java GD for the generation, for the image generation.
I actually don't know.
Yeah, it says use internal.
R is we're not spending a lot of energy on R these days. We do. It's kind of maintenance. We're adding new features. We're adding usually some compatibility, keeping up with R. And there are people who use R. I mean, we got use cases in the community of R users, right? It's very specialized. The problem with R is there's no spec. Right, so this is really challenging for language implementers. There's no spec for R. It's kind of like, some people wrote a thing called R.
Are there specs in Python? You mean? Does Python has a spec?
No, I don't think so.
You see,
nor does Ruby, right? But Ruby is tighter. Ruby is more controlled. JavaScript does, right? So this is why you see us. And I think the notes mention, we've got a very compliant, ECMAScript compliant implementation for JavaScript, and we also are. It's very easy for us to add new features. So in the ECMAScript working group, technical committee, they'll look at new features and we can prototype them pretty quick. So there's a few things in there that I can't remember what the list is, but we've been adding these features and put them behind an experimental flag, right? You can try out the new feature, and it may or may not. But we put them in when we're pretty confident that they're going to actually include it in this spec. But
R is interesting. Also at conferences a couple years ago, there was a lot of buzz around R. So it's interesting that you say, like in maintenance mode. I still thought that R is big, but maybe
it is still for the community who use it. Right? Like everything, right? Everyone has a community. Sure. It may not be front page, but it's out there. It's active. Yeah.
I spend my time in enterprise project. What I see and back then R got some traction, and now I never heard about R anymore. And Python a bit, maybe, and Node.js also. And funny enough, some Java developers assume that Java, you cannot just run Java on Lambdas or in serverless, and they assume they have to learn Node.js or Python. And if I show them that it's actually not only possible, but it works great, and they're already happy. Yeah. So we don't have to learn anything else. We can just do whatever we did and call it serverless, which is great. So.
Yes.
Another interesting part, LLVM. support, and
Yes.
LLVM is actually huge because it's like, if you support LLVM, you support a lot. Question is, if you support LLVM, you could indirectly also support Swift. Is it true from Apple?
Yeah, there's some talk of this. So in theory, yes. There's probably devil in the details. There's probably something that needs to be done. I'm going to guess. We haven't tried.
Yeah, sure.
Right? Also Rust, right? So that's the bigger one. It's the more obvious one, I think, is Rust. I know one of my colleagues is keen on trying out Rust. What we've been focused on is C libraries, C++ libraries. Right, that's the main thing, because you have some existing C++ library. You want to run it. If you run it in our managed mode, which is really interesting, it's an enterprise feature. We can run the LLVM bitcode in basically a sandbox, right? So we're able to, if the C code is untrusted and may segfault on you, then if you're using a normal shared library linked to your JVM, it can bring the whole thing down. If you're running in GraalVM, you get a Java exception back saying, "Oh, that thing failed." So yeah, it's a good backdoor, right, for bringing in other things if you can go to LLVM.
You never mentioned here in the show notes C or C++, but this is just C and C++ is always supported by GraalVM?
Yes, it's LLVM.
Yeah, but this is never mentioned. I mean, this is not obvious, right? You should mention that C and C++ is...
We used to have it in the list of things. I guess we're not really focusing on it much. Interestingly enough, I actually have a customer whose principal interest is in C++ libraries that they don't trust, or at least they don't want to bring down their whole system when there's a problem in the C++ code. They want to.
Yeah, but even let's assume I have some encryption, signing, or whatever algorithm in C, plain C.
Yes.
So I could run it in GraalVM and communicate with Java safely.
Yes, and also very efficiently. Yes, you can.
Now, but this is a huge use case, but it's never mentioned in the GraalVM. So I would say, now I read LLVM and I say, okay, but now, I can use C because we in a web project, we had exactly the problem. So there was a C library which had to be used. And what we did, we cross-compile it to Wasm and run it from JavaScript. It was very similar, but in browser. But I can have exactly the same on the backend.
You can do it with with GraalVM. Yes, you could compile the C library to LLVM bitcode and then load it and call it from Java.
Yeah, this is huge, and C++ as well, right? So with
C++,
object oriented.
Yeah. You just need all the right libraries, right? You need all the libraries. Yeah.
But the standard libraries, I mean, the C had the standard lib in C. I mean, if you're happy with this, then it could work, right?
Yeah, I think that's correct. The C++, I'm something in my brain saying there was some enhancement done in the last year around C++. But this is our use case, and we use it ourselves because some of these other languages have native libraries, especially Python. Python has a lot of, there's native libraries. So they're running on LLVM bitcode. Yeah.
Okay.
So for us, LLVM is kind of infrastructure that we're building on, mostly, like Ruby, Python. They're sitting on top of this LLVM bitcode.
Because Apple also uses the entire LLVM. They use it behind the scenes in the Xcode. So this is why.
They do.
And there's also attempt to run Swift as a backend language. This is why you can also run Swift in a headless mode, so it's open source. And Swift is actually an interesting language. I mean, it looks a little bit like Kotlin and Java. So this is why I thought it could run. Yeah, but you have to focus.
I had the same thought you did some months ago. I thought I'd take a look. I didn't get very far in that investigation. I mostly ended up going down this rat hole of like Swift and open source, and trying to figure out what was open source. It looked like, well, I know there's dependencies on the Mac on certain libraries, and I guess they're on Linux. They've re-implemented it to run on Linux, decoupled from those libraries. But does it suffer from the problem of having like a .NET problem of some of the libraries are definitely just about Apple, and some of the core languages may be portable.
Yeah.
Like to do anything useful, do you have to basically be on a Mac? That's the question.
Yeah. Then the biggest feature, maybe Java on Truffle, right? So we have done, this was the former Espresso, right?
Well, it's codename Espresso. It's internal. It's a codename.
Codename.
It's codename. Yeah.
Yeah. And what about that? So what's the progress?
The most of the work there, I think you see in the release notes, is around hot swap. So it's around a development mode. So we can redefine classes. Even I think we can redefine up the class hierarchy. We can move things around. So it's a really interesting development features. The performance still is not up to the level we would like, right? So it's still in the mode of it's functionally complete, but we still don't have the performance we're looking for. So that's time goes on. So what you see in these truffle languages is work done in one language leaks benefits the other. So this is the good news, right? So we're seeing all kinds of cross pollination. One of the things that you see is these truffle strings in the notes there. There's a truffle string, and also regular expression. We have regexp. So we have a compilable regexp implementation, right? So we can generate machine code from this, rather than running it through some sort of regex interpreter. We actually compile the code. Which is now being shared across, so we can expose that to different languages. It's a common implementation. And same thing with these strings. We have these truffle strings, which all the languages are slowly adopting support for them, right? So we're using, I can't remember which language is the core language, was using it, but then it's spreading. So other languages, implementations will start adopting these truffle strings.
So what do you mean by truffle string? Is like truffle is the canonical string which all languages are supposed to use, and then they can easily
in their implementation, right? It's not the language. Like the languages have their own string definition, but under the covers, there's a string class, and so this class is designed to be more give us some performance benefits, efficiencies, right? So this is what I'm saying. You see that if you look at our notes, you'll see such and such a component has adopted truffle strings. Because it's sort of making its way from the feature works, it's working great in this language. Now we're going to spread out, use it some more.
And now the annotation thing is still making me curious, because what it says is every annotated element and its classes method fields will be included in the image regardless of reachability. It may require some configuration changes, especially for dynamically generated proxies. For example, using the following code, and there is one example class with one annotation, accessed annotation, and non-access annotation. So the question is the access annotation comes from GraalVM, or is it just my annotation? This would be interesting to find out. So this is in the show notes.
This is looking through my own notes here. You're looking at the release notes?
I'm looking at the GraalVM org release notes 22.1. And it is, I would say, there's the table with the performance, and then maybe 10 points later with the image. So there's one screenshot with access annotation and non-access annotation and the class example. And if you search for every annotated, you will find that.
Every?
Annotated.
Every
annotated element.
Oops. Oh yeah, okay. I have not used this feature. That's our problem. There's too many small features to keep up with.
But this feature could be big or not. So it really depends. But it looks like...
They're basically saying that they're forcing it in, right?
Okay.
Forcing it in to be included.
Yeah. But if forcing to be included is a good news, because if you annotate, your classes, then this is your configuration, right? I mean, then it's included and it's done.
I would have to check the docs to make sure it does what we think it's doing. Because you can do this in... you can certainly provide textual configuration, right, to manage classes. The reflect config class, right, or reflect config file to force things in that we don't think should be included because we can't find it through static analysis.
And then, not a recent feature, but GraalVM also comes with Visual Studio Code tooling. So can you tell us about this? So maybe not in 22.1, but in general. So what do we get with Visual Studio Code and GraalVM? This could be interesting.
Right. So what we start building out is we want support for, because just in terms of siblings, right? So we have the Micronaut work that's going on in a sibling group. We wanted good tooling for that. We wanted also support for polyglot debugging. So that was
by the way, Micronaut is great. By the way, super idea. And what I like about Micronaut is that this similar idea to Quarkus, but it works completely differently with annotation processors. And what also interesting is that Micronaut will support more and more of my stuff. It means microprofile and then almost Java E. So we get another very capable runtime, actually.
You're close there. So if you look at the Helidon team, so they picked up things like Micronaut data and a few things, right?
Exactly.
And they're working on, and we discussed this last time, but they're working on that reflection-free CDI, right? So all these things, yeah.
CDI Lite, exactly.
CDI Lite, yeah, thank you. So there is work going on there. I like Micronaut just because it basically pre-computes everything at build time, right?
Exactly.
That's the key thing. Reflection free, right? Which for native image is awesome. Because
but reflection free, but it behaves like a reflection. This is actually the crazy stuff, right?
Yeah, it looks like it. It's implementation difference, right?
Yeah.
Like those annotations for dependency injection are declaration of intent, like what you want.
Yeah, but for the listeners, what it means is what they're actually doing in Micronaut is at build time, they can connect to database, fetch the metadata at build time, and then decide whether the query will compile or not, and they are basically type safe. And if you don't do this at build time, you will have to do it in runtime, and then you do it dynamically. So what it means is they do everything at build time actually dynamically because it doesn't matter. And at runtime, they are static, more or less.
It's just code. Yeah. So if you look at like dependency injection, when you say something like,
but you say yes, but
class.
This is completely non-obvious for all enterprise Java developers. Yeah, this is like if you think about this the very first time, you say, of course it can be this way, but I mean this is completely different. This is like
this is the big thing. The big contribution is we can compute this
exactly,
right?
Yeah. Exactly.
So the dependency injection is the simplest one, right? So if you say I've got a project with some main program and some bean. And in the main program, you say, I want to inject the bean, right? You say, then Micronaut just looks at that annotation processor, sees the injection request, basically says, the project has this only one. It actually generates classes behind the scenes that basically do the work, right? So rather than saying, here's some reflection at runtime, or config file at runtime, like Spring traditionally had done, right? It would read the configuration and annotations, use reflection to kind of build things put together. So there's lots of logic in Spring, which is like reading things and trying to figure out what to do. Micronaut case is they just generate the machine code. They generate the classes that say instantiate this bean, plug it in here, right? And then they compile that code. So if you're in an IDE with Micronaut and the annotation processor, if you look in the output, you'll see a whole bunch of classes that you didn't write, right? Those are the classes they're generating to do all the work.
Like in early Java EE days, right? Where everything was generated at deployment time.
Basically, it's actually it's kind of similar, yeah. So nothing is ever new. But if you think about the advantages, the classes, like there's no parsing, right? This actually another step. That's not true. Actually, that's not true. There's still a property file with Micronaut, application.yaml, and various versions of that. And if you look at the work done, this Micronaut AOT, which coincidentally, the name is a bit confusing, but Spring team also blogged the same thing the same week. Micronaut and Spring both did this, which is they're now have projects to read all config and generate code for it, right? So pre-compute the configuration as classes so that boot time is faster. And it means you get less flexibility in the sense that if you're you're deploying to, say, Oracle Cloud or AWS, and you're going to make some decisions based on that, it can be baked into during the build. But it saves the compute at runtime. Say, what platform am I on? AWS. I should go get this database driver. It's just pre-computed. And so Cedric blogged about that. I'll give you a link to that and share it with you. It's really interesting. And like I say, what's interesting is both the Spring team and the Micronaut team were doing the same kind of optimization because they realized
Quarkus
that all this parsing.
In another context, what I know is there's like a Liquibase, for instance, the database migration tool, and depending on database, because if they use Postgres, they deactivate all the other stuff. So they also do database-specific optimization.
Right.
Yeah, which is and by the way, what you get out of that is you get the dependency injection errors at build time, because if you, let's say you have an interface and two implementations, and if you would like to attempt to inject the interface, you get ambiguous dependency error. With Micronaut and Quarkus, you will get the error at build time, and all the other applications have it at runtime. Exactly. But the error is exactly the same. This is interesting. It looks exactly the same. You know the error, but it happens at build time. This is actually a huge benefit of the how to call it, build time deployment. I call it. Right?
Yeah, we see this too in just creating REST APIs. So you annotate. You create a REST controller in Micronaut. You'll say you bind a method. It's like JaxWS, right, or JaxWS. You just bind a method to a path with a parameter, and then Micronaut will say, okay, let's say it's like /person/name. It's curly braces name. That's the parameter, and then in your method signature you say string name, right, and then Micronaut will generate the code appropriately because of convention. But at build time, you can be told, hey, that doesn't work. Like your string you typed in for the path doesn't match the parameter, which in a Spring application it would fail at runtime. You'd be like mismatch, right? Can't find the parameter or something like this. So it's true, right? It's an obvious thing you could fix it at build time, and even if you didn't generate code, if you didn't do the Micronaut thing, you could at least check it, right? It's a checkable error.
Yeah, interesting.
And then you have to buy into the annotation processing. Right?
Interesting that Oracle became, the sponsor of the most lightweight framework on earth right now, Micronaut, right? So,
yeah, I mean, it's basically, we're supporting all frameworks. We're working really closely with Spring team, like the Spring native team. We have lots of friends, I guess. We like Micronaut because it's 100% new from the ground up, very aligned with native image. Right, so this is great, right? At the same time, Spring is a huge force in the market, right? Like it's a huge presence, and so we want to make sure we work really well with them. And so you'll see things like those build support, like Maven Gradle. We work with the Spring team on lots of work to fix problems that Spring Native has found or alignment. So that's a really productive partnership. And then even the Red Hat team, they've even got Mandrill. Basically, they've got a downstream build of native image in the native image. Sorry, in the GraalVM GitHub repo. Like, so we're working with everybody. Because at the end, Java developers just want to do their. They want to use their
tagline like in Oracle, everybody's darling, or something like this, right?
Everybody's darling. That's it. I don't think that's right. I don't think that's the marketing that Oracle's been using.
Okay. Back to very briefly to the Visual Studio Code tooling. So, this is because Micronaut was too interesting. But I mean, what we get with the Visual Studio. So let's say I would like to have a small, Hello World GraalVM project. So how Visual Studio Code can help me? Yes,
you can create a project. There's wizards for creating a project, instantiating it, setting up the environment. Behind the scenes, what's interesting about this is behind the scenes, actually NetBeans is running back there. So the NetBeans language server is being used for language services. So code completion, all the usual Java stuff is all back there with NetBeans right now. But like I say, for us, this is just basic Java support. We also have this other use case with multiple languages, which we just, at this point, we can't get somewhere else. Right. So if we want to have JavaScript, if you want to have even Java code with JavaScript embedded and step from Java into JavaScript in the same, environment, that's something we can get out of these tools.
By the way, I would use NetBeans more often. The problem I have with NetBeans right now is command space shortcut doesn't work, which is annoying. This is the only. But other than that, you should try NetBeans because it is
command space on command space on a Mac is Spotlight.
You mean but it works. I know, but it works actually in all other tools, and it worked actually in NetBeans, but it doesn't work for 1 year or 2 years. Command space is. I don't even know. I just
must be control space.
Or control space,
No.
Control space.
Yeah, it's control.
Control space, of course. Command space is Spotlight. Yeah,
Spotlight,
I use it for launching application all the time.
Right.
But NetBeans is actually quicker than Visual Studio Code. It feels incredibly fast. So if you work with it, the editor is crazy fast. So it's a pity that
Visual Studio Code is interesting. Like it's gaining some traction. I don't know if it's going to take over the world, but it's certainly gaining some traction. It's open source mostly. I mean, VS Code technically is not open source. The Thea project, based on the sources, is a fully open source version. It doesn't have any Microsoft metric gathering and such like that, right? And then I see that just yesterday or day before, NetJetBrains announced a partnership with Gitpod, which I thought was really interesting. Have you seen this?
The Fleet project? No.
With Gitpod.
Gitpod, because the new IDE is Fleet. It's like a cloud-based IDE.
Yes. Right. So if you've used Gitpod before, they were using Eclipse Thea, which is VS Code, let's say, where you can be in GitHub. They install a button for you. You install the extension, click the button, spins up a container environment, checks out your code, and then gives you a web interface with VS Code into that code. So you can basically debug your code, build your code, all cloud-based. And they just announced a partnership with IntelliJ to do the same thing, to bring their web IDE to Gitpod. So you can really, at this point, I guess, get a choice between which IDE do you prefer. And Gitpod are saying, we're not really in the IDE business, we're in the cloud development platform environment. So that's pretty interesting. So JetBrains is catching up, right?
Yeah. And I think Gitpod is even a German project, right? So I think
Yep, there's a bunch of Eclipse guys from Eclipse,
for Smalltalk, right? Smalltalk.
No, there's Java guys. No, actually, no.
Java
Xtext. Did you ever see Xtext?
Yeah. This the code generator was huge in Germany. So this is the MDA tooling and Xtext.
It's Sven. Is it Effinger? I'm not sure
Effinger. Yeah. Bright guy.
So yes, bright guy. So he's one of the principal. He's the co-founder of Gitpod.
But back to Visual Studio Code. What I think is maybe in one point of time there was something. I know there should be competition because Visual Studio Code is not as snappy as it could be, right? So it is perfect, but it feels a little bit too slow. And what I know is that the community was always sensitive, for speed. So I always got, the arguments like VI and Emacs and Sublime and Ultra Edit, whatever. Always the argument was speed. So I don't care. I like Visual Studio Code. I actually use it all the time right now. But I noticed that actually the feel. It is lagging a little bit. So and it is hard to describe because it is Chrome based app. Basically, right? It feels like Slack, more or less. So it is.
Yes, Slack and other things. Yeah, it is. It's like Electron or whatever, right?
Yeah. So I'm just waiting for the true native implementation of that something. So
I guess it's like basically it's Node, right? The front end is Node based, really.
Yeah.
I don't know if it's the IDE itself or whether you're doing Java, whether it's because you're talking to these language servers.
Even if I use JavaScript without language servers. It is like the editor, or it is like until it starts and does something. Because I have lots of projects and opening, closing all the time. My Visual Studio Code. This is one of the reasons why I'm using a lot, because I go to folder code -n dot and it opens, right?
Yeah,
and do something with it. But it's still. I noticed that it's not as snappy as it could be.
But think about it, right? Think about it. You're hitting JIT problems. It's a warm up problem, I'm sure, right? You're running your JavaScript code on V8.
Yeah.
And it has to warm up.
Yeah, sure. I'm still happy, but I'm saying that if someone would rewrite a part of that, in Go, Rust, or GraalVM, it will take off again. I think because the arguments. So if developers say no, and now I have IDE and it's really really fast and not Node.js, then it's fashionable again, and everyone will use the new thing. So this can happen. This is.
I don't know. I don't.
Because Eclipse was huge.
Slow.
Remember Eclipse? It was like everywhere.
Yeah.
So it was like millions of plugins and whatever. And the argument was always, is this heavy and slow, which was not true.
Not true. No.
But there was still the argument. No, this is why.
Yeah, I didn't have a problem with Eclipse. I mean, I worked on Eclipse plugins, right? Like IDE extensions for JPAs, our team, right? So I use it all the time, and I'm a big fan. But I have to say that like VS Code is not there yet, right? This
is what I think. So from the performance perspective, I would even say that Eclipse should be faster than VS Code, right? So from the feeling, if you're editing speed.
You've got. I mean, ignoring the implementation, you've got Node code, TypeScript, Node, JavaScript on V8, which is optimizing good JIT compiler, and then you've got Eclipse, which is Java bytecode. It's running on JVM, good bytecode compiler. So, I don't know whether Java's probably faster in the end.
Yeah,
but I'm not sure what the differences are.
I was not sure. I thought that you're using both. So if you use Eclipse editing Visual Studio Code, you can tell me, is it there's a difference? Because
Eclipse is pretty snappy. Pretty snappy. I don't know. I don't use IntelliJ much. That's the one. I'm an oddity that way. So I don't know whether it feels the same way. It's all swing based, the old one, right?
IntelliJ. I think it's hard to tell because it needs longer for initialize, and I don't think IntelliJ is well suited if you're jumping too much between projects. So it's really hard. You have your workspace, and this is heavier. So I have a license, but then I prefer Visual Studio Code if there's not lots of refactoring going on, because I just open without the ceremony a project without millions of questions whether how to include the Maven. So I would just like to open it and work with it, right? So whatever happens.
Yeah, it's good as a text editor. That's how I started. Right, I go to conferences. You pop up. You want to show some Java code?
Yeah,
Studio Code, right?
Perfect.
Because it just shows you nice highlighted code. Yeah. And slowly but surely, I'm starting to use it for more actually building things like with Maven projects and Gradle.
I use it actually full time now, Visual Studio Code. So there are no Java actions like it generates unit tests for you. You can swap between unit tests and the production code. The refactorings are good. You can generate constructors. Actually, I would say it is 80% there. So from the from the functionality, but it's a completely different topic. So how
IDEs are a very religious topic.
Yeah,
favorite IDEs,
even more than Python, maybe, right? So
yes, possibly.
So it was really interesting, and we should invite you back on the next release, right? So I would say in the next 2 releases, and then let's
you should skip 2. Yeah, so the next one. The final release of the year is always the big one, right? So 21, the X.year.3 is the final one where we're wrapping
Christmas
up
release.
the work. Basically, yes, Christmas release.
Yeah.
But in terms of long-term support, so there's some changes for us. So it's more maybe the enterprise side, but we are aligned with Java, the Java LTS schedule. So which put us in a funny position because we had a long-term release which is 20.3. We did that. The next year, we've now aligned with Java. They have 17. That's in the long-term support release. So now we have 21.3 also. So we have weirdly 2 years in a row, we have these LTSs, which for our support team is just more streams to backport to, right?
More branches to handle, right?
More branches, exactly. More branches, more builds, more testing. And security, right? We have regular quarterly security updates, CPU. For Oracle JDK and OpenJDK. So there's more work for us. But we're aligned now, which means that the next long-term support release for GraalVM will be 23, because that will be Java 21. Is that right? Yeah. No. It's 4. 21. Yeah, that's right. So okay. Java also changed, right? Java changed to a 2-year cycle. Right? So we're aligned. So that means that means that this release here, and people who are using the GraalVM community, they don't really care. But that means that normally an LTS release, we're going to try and squeeze things into the LTS release because it's going to be there for years. And if you want a feature, right, to be supported and to be used by customers in long term, or used by customers, they want it in an LTS release. They don't want some feature release. So anyway, so this year is not a long-term support release.
No, but Christmas release is still coming. So
we'll still do it. Yeah, we'll still have Christmas. Okay, we'll call it that.
Yeah, okay. Or Santa release. Depends on the marketing. Okay.
Yeah.
It was really fun to talk with you again about, especially, performance M1 versus, the MPR and different options is always fun. And I know that you also love Python even more than Smalltalk, right?
I don't know Python almost at all.
I've
written some Python. I wrote some database testing with Python.
I only know that it starts with def sometimes, right? Def, DEF, and then you write something def. Yeah.
I think it's time to learn some Python because everyone I know is like, Python's great.
I also think so. That I actually wanted to learn Ruby, but it didn't disappear. It's okay, fine. So I saved some time. I hope that the Python will disappear, but
well, we should do a podcast, on all the languages that we use that are dead now, right? Because we were talking today about awk, which is actually still very useful, awk. But I looked at Icon. I don't know if you ever saw Icon. It was a string. It's focused on string processing, and I remember, I used Icon. Had interesting features, and I hadn't thought about it for a long time. But there's these languages that come, and then they maybe they're researchy. They never really escape the research.
Yeah, I wrote a short blog post because I'm in the situation. I don't know. I get constantly asked why I'm still using Java and not whatever. That's the problem I have, right? So at the beginning, I remember I was asked why I'm not using Jython. So Jython was very early, actually. So really early, and people asked me no Jython. Then Groovy came out, and Groovy was I remember JSR, Java Specification Request for Groovy. So it was standardized, and I got questioned, why I'm not using Groovy, and Groovy will take over the world because Grails and whatever. And I say, yeah, but
Right.
I mean, Java is good enough. So then Groovy disappeared a bit. Then Scala was big.
Yeah, Scala was big.
Yeah, and definitely. Why? In my environment, enterprise, everyone thought Scala will win and Java will lose completely because Scala had built-in XML parser support. This was the big deal. So okay,
at the time,
I was not. For me, XML was a little bit better than YAML, but not very appealing to me. So it was the all ESBs and SOAPs. I didn't want it, to have something to do with it. So okay, then let's see. Maybe Scala will disappear with the XML support, which happened actually more or less. And now I got questions about Kotlin all the time. So okay, Kotlin is nice. But Java 17 is also great, and it is not like I'm missing features. So I really like Java 17, and and I'm happy. So I'm just this is I get every second year Salon from Red Hat. So why I'm not using Salon? So okay, because there is no need in my project. So this is my standard answer, and then somehow whatever I was asked, it's not no more that popular, and Java just is it remains somehow popular language, I would say.
It's amazing. It's amazing. Yeah. I'm actually surprised, right? It's still around, and it's a testament to the community and the governance of Java. But most languages don't last, right? They come, they go, they reach a peak, and something new comes to replace it, right? So Java being 25, 20, what year is it now? It's 27 years old, I think. It's amazing. Right? I mean, what else? I mean, C++ and C, I guess they're still around, still popular.
Python maybe, right? So it's also...
How old is it though?
No?
Is it? I don't know. When did it...
I think it's maybe 1 year younger or something, but this is old language.
But some things, but Python, weirdly, now is gaining popularity, right?
Because they had a new version, right? This was the Python 2000, whatever.
So they 2.3 thing.
Yeah. Okay. But completely different story. Sean, thank you. Where people can find you on the internet?
Oh, on Twitter at Sean M Smith. Middle initials, so Sean M Smith. SHAUN M Smith. That's where I'm mostly. It's Twitter. Okay. Although I don't know, Elon Musk has just bought it, so who is buying it? Has bought it? I don't know. We'll see if the world ends on Twitter. I don't know, but otherwise,
now it is everything going to be better now. And I assume GraalVM is also on Twitter, right? So
at GraalVM.
Yeah, perfect. Yeah. So if people can have some questions to the show, then can just
please hit me on Twitter for sure, and I'd love to have questions on Twitter. I mean, it's funny because we have these different channels. We communicate with LinkedIn, channels for GraalVM. We've got all these things. And LinkedIn is surprisingly busy place. I mean, I don't really use LinkedIn too much, but...
no, I don't even have an account. So on LinkedIn.
Oh, okay. Well, then
I only have a Twitter account, and only Twitter. I don't have a Facebook account and also don't have LinkedIn account. So I saved, like the other languages, saved a lot of time with the...
I know, right? I don't have a Facebook account either. I'm probably like... that's probably insane, but I figure that it's peaked, right? Peaked Facebook.
Yeah. Perfect. And then see you next time and talk about the Christmas release.
Okay, great. Have a good summer.
Bye.
Okay, bye-bye.